My name is Martin. I have the pleasure to be third time at JavaDay Kiev. I'm currently running my own consultancy called Coffee Cup Consulting. This is the code name of my company. I'm also one of the guys who is responsible for helping out with the events that we organize in the Bulgarian Java user group. We also have our own community conference called JPrime, which runs in May. I'm also a big OpenJDK enthusiast, and just recently I authored a book on RabbitMQ. So if that topic is of interest, you can ask me about RabbitMQ after the session. Just 2 years ago, I had a session here at JavaDay Kiev where we discussed basically the security architecture of the JDK. How many of you are familiar with the sandbox model of the JDK and how the security manager works? Not many? Okay, in the talk, basically, I have an introductory part. So first, we'll see how does the security sandbox model work in the Java platform. We'll do a very short revision of that. It's something that's been around since Java 1.0, so it's not something new. It's been around since the beginning of the Java platform. Then we'll discuss the security aspects of the new module system that's coming in JDK 9. And we'll see basically how the security sandbox model apply to the module system in Java 9. And in the end, we'll do a very short comparison with the de facto standard module system for Java, which is OSGi. Before Java 9, basically, OSGi was de facto the main way to create module systems in Java. And we'll do a short comparison of what is the security model in OSGi compared to the one in Jigsaw. So first, the security sandbox model of the Java platform, a very short revision. This is basically the big picture of how does the security sandbox model in the Java platform work. You might have a managed environment such as a JavaDay application server, an OSGi runtime, or even the user's browser. And in that managed environment, you load some different kinds of applications. These might be applets, WAR files, bundles, depending on the type of environment you have. And the JVM that runs inside this managed environment provides basically the capability to do permission checking over the different applications you load into that managed environment. For example, if you have some applet that's loaded from the JavaDay UA site, you can specify that this applet has the permission to delete the C Windows folder. And you specify that permission in the so-called Java policy file, which comes with the JDK installation by default. In order to supply that permission checking mechanism, the JDK provides the so-called security manager utility, which is basically the standard utility in the JDK platform that allows you to do permission checking. It basically takes the permissions that are specified on the currently running code and does the permission checking based on what you've specified. By default, when you write Java applications, they run in an environment without the security manager installed. But if you deploy applications typically in a managed environment like JavaDay, OSGi, and so on, those environments have some kind of security manager installed. Now, to give you some more ideas on how this works, let's follow a bit the steps of permission checking in the JVM. So upon startup of your application, the security policy file is loaded and is set as an instance of a policy class. And that's done by calling policy.setPolicy. This line here is typically done just before setting the security manager instance used by the managed environment. And then the application server or the JVM running in the browser installs a security manager that's responsible to do the permission checking by calling system.setSecurityManager. At that point, you have a security manager with some security policy in place installed in the JVM. At the second step, class loading starts. All of the classes of your application are being loaded. At that point, there are stuff like bytecode verification that are being done on the code base. And also during class loading, the protection domain is set for the current class loader that loads your class files. The protection domain basically defines several things like where is your code loaded from? Is it a jar file? Is it a class file? Is it some other package? What is the set of permission that applies to this particular code location? For example, for this particular applet, I can open a socket connection, I can delete a file somewhere on the file system, and so on and so forth. And also you might have a set of JAS principles The JAS principles basically provide you with the capability to specify who is the user executing the code, or who is the current user that's authenticated in the system. JAS basically is a standard API that comes with the JDK platform. It's been around since JDK 1.2. When the classes are loaded, the protection domain, as we mentioned, is set. And basically, from any class in your application, you can get the protection domain by calling .getProtectionDomain domain of that class instance. And this can return you basically the location of where your class is loaded from, the set of permissions that you have for that particular class, and the set of user principles that apply for that particular protection domain. And in the JVM, you have two types of protection domains that are system and application. As you can notice, basically the system protection domain applies for code that's part of the JDK, and the application protection domain applies to the code that's loaded from your application. So when basically the classes in your system are loaded, the JVM or the application server or any other type of managed environment may do permission checking at any point by using the security manager that's currently installed. And in order to do that, it calls basically security manager.checkPermission. This is a very brief example of how you can do permission checking. For example, in an application server, you create an instance of socket permission, and that socket permission specifies that I basically may connect to the JavaDay UA website between ports 8000 and 9000, or I can also accept connections from that location. Then I check whether I have a security manager installed. You need to do that check because, as I mentioned, by default, Java applications don't come with the security manager installed. This means that you might run your code in an environment with all permissions or no security manager. And if there is a security manager installed, you call security manager.checkPermission, and you pass that permission. When you do this call, basically, what the JVM does is it traverses the full stack trace of where that execution comes from, and it basically checks whether every frame in the stack has this permission that's specified here in the check permission call. This means that your stack may pass through different class loaders. You might have different protection domains with different set of permissions, and all of them need to satisfy that permission so that this check is successful. If it's not, you have a security permission exception. When that's basically being done, applications themselves can also use the security manager utility. Inside the JVM code base in the JDK, there are a lot of places where there is this call done. So basically, when you, for example, open a file output stream, the JVM behind the scenes first checks whether you have the permission to write to the file system. And if that's the case, it grants you that ability, otherwise not. And you can do the same in your managed code. Basically, you can use another API which is called Access Controller. Access Controller is pretty much the same thing as a security manager, with the only difference that you don't need to install an Access Controller in your runtime. You can use the static methods provided by the Access Controller API to do permission checking. In that particular example, to check whether I have this socket permission, I just call access controller.checkPermission without checking whether I have a security manager installed. And also I can do other things like escalating privileges by calling access controller.doPrivileged and supplying some chunk of code. I can just skip all of the permissions that are required by calling code at that point. I'll show you an interesting use case for that during the demo. And also you can change the current user that's executing the code by calling subject.doas, or combine both operations, changing the user and escalating privileges. Now, to show you an example of how this works, I'll demonstrate using a very simple custom application server. I've developed a very simple application server that makes use of the service loader utility. The service loader utility basically is the main utility that's also used by the Jigsaw module system. So it's not by coincidence that I choose service loader. And basically that simple banking application server loads different applications. Two of them are different implementations of some banking protocols that are provided by the application server for use by applications. And one of the applications is a demo application that demonstrates the use of one of the two protocols. And I'll be using that demo scenario to demonstrate how the security manager works. So let's go to the demo. So first of all, I have a few projects. I have my application server. The application server is quite simple. It basically uses the service loader utility and iterates over all implementations of the banking application interface. All of my applications need to implement that interface so that they are recognized by the application server. And I'll be using a very simple deployment model. All the applications will be put on the class path. So when the application server starts up, it looks for the class path to find all implementations of the banking application interface. And then I simply execute, call the execute method. What else do I have in my banking application server? So this is the banking application interface, very simple. I just have an execute method. I also have an abstraction for a banking protocol. A banking protocol basically has a name, and it also has an execute method that provides you with the ability to send a particular message using that particular protocol. Also, I define a custom permission, which is called protocol permission. Basically, the permission model in the JDK is quite extensible. You can create your own types of permissions. And in that particular case, I create my own protocol permission that can be used by applications, so that basically the application server can check whether my particular banking application has the possibility to use a particular protocol implementation. And I also have a service that I provide to my applications. It's called the protocol service. It has a method which is called send packet. And in that method, basically, I provide a binary stream for the packet message and the name of the protocol that I want to send that packet message through. And that's pretty much it, the whole implementation. Now, I have two concrete implementations of the banking protocol interface, which are the fixed protocol and the alpha protocol. They are quite simple. They are just one implementation class. The alpha protocol has a name of alpha. It has some logic that provides you with the ability to create a packet for that protocol. And it's pretty much the same with the fixed protocol. It also has a name of fix and the ability to send some message to the fixed protocol. Now, my demo application, basically, as I mentioned, needs to implement the banking application interface. And what it does, it basically creates a new instance of the protocol service that's provided by the application server. I include basically the API of the banking server as a provided API for my demo application. And I get from my banking server API the protocol service and call send packet by specifying the fixed protocol. So I want to send a message from my demo application through the banking server using the fixed protocol. Now, if I run this example, I've specified on the class path of my application server the two protocol implementations and the demo application. So if I run that without a security manager installed, as you might guess, it's executing fine, and it prints out that I'm running my demo application, and it's sending some message to the fixed protocol implementation that's provided by a separate project. Now, what will happen if I install a security manager? I just call system.securityManager and I specify the default security manager instance. You can create your own if you want to do some more complex type of permission checking. If I do that and run the code, nothing happens really. And the reason is basically because the service loader utility requires some additional permissions for class loading that's done behind the scenes. If you go to the documentation, you won't find directly what are the exact permissions that you need to specify for your application so you can execute that service loader.load call. So one way to do that is to specify all permissions for my application server. Typically, the code base of my banking application server has all permissions on the file system. In order to do that, I need to go to my JDK installation, and inside of it I have a Java policy file. This Java policy file basically specifies all the permissions to all different locations from where I potentially may load my source code. Now, for the application server itself, I'll specify the permissions on the target classes directory, because this is the directory that contains the class files for my compiled banking server. And I say grant code base. I specify the location of my application server, and I specify that I give all permissions to my application server. When I do that in the Java policy file, I go back to my application and I try to run it again. And when I run it this time, it gives me target protocol fix not found. Okay, so this means basically that now I'm able to discover the demo application, so this call passes successfully. However, if I try to execute the application by calling the execute method of my application, this call eventually fails. And it fails basically in the service, in the protocol service implementation. And I'm wondering what's the reason. Do you have any ideas what's the reason that this call fails? I'll highlight in particular that code. So my demo application basically calls the protocol service, which also uses the server loader utility to load basically all the protocol implementations and to do a lookup of what's the protocol that I need to retrieve in order to execute. And that call here basically also needs runtime permissions to do some class loading. However, I haven't specified any permissions for my demo application. So when it uses the protocol service, it doesn't have the required permissions to do that call. And at that point, this line here doesn't return me anything. It doesn't throw an access control exception because this is the way that the service loader class works. However, it doesn't return any, it doesn't find any implementation of the fixed protocol. Now, in order to do that, I may delegate that responsibility to my banking application server, meaning that at this point when this code is executed, I don't want to check what are the permissions of the application. I just want to find the list of all protocols I have in my system. And in order to do that, I need to escalate the privileges of this current piece of code so that I don't do permission checking for my demo application. In order to do that, I'll be using the access controller.doPrivileged method. Here I need to specify some privileged action, which basically encapsulates the code I need to execute in an escalated manner. And that privileged action basically has a generic parameter where I specify what's the return type from my action. In that particular case, I want to return the banking protocol implementation. And inside of that block, I need to implement the run method of that privileged action, where I'll put inside this chunk of code. I need to do some minor modifications. And basically the code is the same. I just return the target protocol when it's found. Yeah. At the moment I'll comment out this. So I need to move that target protocol outside my privileged block. And I need to make that final. No. Okay, probably I'm missing something simple, but I'll use my so basically what I need is to assign the result to that banking protocol. As I said, basically my privileged action returns an instance of the target protocol. And now, when I run again my application server, this time my demo application is able to find the fixed protocol through the protocol service, but I get a security exception, which is that my demo application doesn't have the protocol permission to execute some packet through the fixed protocol. And that basically exception is thrown again from the protocol service, basically when I try to send a packet. The reason is because I take the security manager that's installed in the application server and I do a check whether my application has the permission to specify to use the fixed protocol. Now, in order to provide that permission to my application, I need to go again to the security policy file. and I need to specify that my application has the permission to use the fixed protocol. Again, I specify that the code base of my demo application is a jar file that I've compiled for that application, and I specify that it may use the fixed protocol through the protocol permission. When I specify that in the security policy file, I go back to my application, run it again, and now it works fine. So basically, this is the way basically you need to work if you need to specify the set of permissions that applies to your applications. You need to carefully review what permissions you need. In many cases, developers are tempted to use all permissions for the applications, which is not a good practice. So basically, this is how the security sandbox model of the JVM works. Now, if we extend this concept to Project Jigsaw, we can have a picture that looks like this. In the system code base of the JVM, we have a number of modules, such as Java logging, Java base, any other application module. As you know, basically, the JDK is split into a number of modules, and now the code base is not a big monolith, but rather a set of modules. And now every module in the JVM is a subject of permission checking. So basically, you can specify different set of permissions for each particular JDK module, which was not the case with earlier versions of the JDK. And basically, permission checking on Jigsaw modules is specified in exactly the same manner as we do with jar files or regular class files. We use the security policy file to specify that from the location of a particular Jigsaw module, I can have some certain permissions that I specify for that Jigsaw module. So as you see, basically, the security model remains exactly the same with Jigsaw modules. However, there are some interesting implications on that. So, as we mentioned, the security model remains exactly the same. However, now that the system code is split into multiple modules, this means that you can control different permissions on different levels at the JDK. For example, Java util logging may require one set of permissions, which is not the same for, let's say, Java SQL. And this was not really easy to achieve with earlier versions of the JDK. So basically, another implication is that you can split your project into Jigsaw modules, and you can specify different set of permissions for each module. In that case, you can improve the application of your project by providing more fine-grained permissions per particular module of your project. And the other thing is that, as you probably know, there were a few sessions yesterday about Jigsaw. It provides another layer of encapsulation. It basically allows you to explicitly specify which packages you want to export or which packages you want to open to other modules. So in that regard, basically, modules in Jigsaw provide an additional layer of encapsulation at runtime, which further improves the security model of the JDK. And another interesting implication of that is that typically classes in one module might be loaded from different class loaders. And this is an interesting implication because, as I mentioned earlier, typically the protection domain or the location of where your class is loaded from is guided by the class loader. And with Jigsaw modules, since we might have multiple class loaders, this means that we might have different set of permissions that apply for the different parts of the module. And yeah, of course, we have another layer of encapsulation, which is provided by the ability to specify exported and open packages. Now, if you want to review some details about the module, you can get an instance of that module at runtime by calling the getModule method from any class you have at your application. And out of that module, you can get the module layer, and you can also dynamically define modules by calling defineModule. The layer instance here basically is a capability to specify different class loaders for a group of modules. So a module layer is a way to group modules in terms of the way their code is loaded. And in that regard, basically, the module layer may have specific set of permissions that applies for a number of modules. Now, let's look at an example of this. What I'll do basically, the application server I've just showed you, I'll modularize it. So in order to modularize my application server and the applications that use it, I need to specify some module metadata in a module.info.java file. I'll not give you many details on the contents of that file. So basically, I just create my module info Java files. And the next thing basically I would like to do is to compile my applications as modules. For that reason, I'll be using JavaC. Now, one thing I want to show you before that is I'll first remove the notion of security manager again. I'll run my application without the security manager. And some of you might think basically that, as we said, the Jigsaw provides you with an additional layer of security using exported or open packages. If we look at an example of whether that's true, I'll show an interesting example where you can easily basically at runtime export a package. I'll take as an example the logging module. So what I have here, I first take the module of that represents the JavaUtil logging module in the JDK, and I first check whether it exports the sunutil logging internal package. As you can imagine, this package is private and it's not exported by the logging module. However, with some inspection of the code, I can at runtime export that package. What I do basically, I get an instance of the logging class, basically the module class, has this everyone module variable, which represents all modules. It just creates an instance of new module by passing null. So I get an instance of that field. I make it accessible because it's private, and I use the impl add exports or opens method from the module class. The reason I want to do this is because I first wanted to use another method, which is called @reads. And basically what I wanted to do is I wanted to use the @export method to provide that internal package as an exported package in my module. However, when I tried to do that, I got a security exception because basically this method is a subject of permission checking. And in order to do a workaround this, I had to use another method which is not a subject of permission checking. This is this impl exports or opens. I make this method accessible as well. And then basically what I do, I invoke this method by passing the name of the package, the name of the module, the logging module, and all modules. This is the variable. So I specify in a way that I want to export this internal package to all other modules. And when I do that, I check whether the sunutil logging internal package is available, is exported from the logging module. If I run that, first need to clean my project. I'll just comment the module metadata for now. If I run that, I see that first check is false. So basically this package is indeed internal. However, when I do this runtime magic in between, I can effectively see that without any difficulties, I was able to provide this package publicly exported by the logging module. However, as I see here, I have some interesting warnings, and those warnings basically tell me that at certain point in future versions of the JDK, this reflective access might be deprecated. However, in Jigsaw, they added something which is called open modules, and that basically provides you with the ability to specify that one module can use reflection on top of another module. And in order to do that, I need to use a special flag for JVM called open module. And if I do that, if I specify this @openModule flag before I run my class, I basically say that I want to provide the capability that I can use reflection from Java.base module to Java.lang module. And I use for that reason the @opens clause when I run the JVM. So I apply that, run again my example. In that particular case, the warning is gone. So in a way, you can specify that you want to enforce this capability to use reflection from one module to another. However, as you can see, we were able to relatively easily work around the sandbox model provided by the modules themselves. Now, the other thing I wanted to show you, basically, another cool thing that's provided by JDK 9 is the ability to create a stripped down version of the JDK, which has just a subset of the modules from the JDK. And as you might think, this further improves the security of your application, because now, instead of 5,000 classes loaded from the JDK, you might have just the classes of JavaUtil logging loaded. In order to do that, I'll go on the command line. I'll navigate to my JDK 9 installation. It's the latest one, which I downloaded yesterday. And it provides a tool called JLink. With that tool, basically, I can create a new JDK runtime image, which only contains just certain modules. I'll specify module path, which basically specifies from where would JLink look for modules. In that particular case, I'll specify the JMods directory, which is part of the JDK. The JMods directory basically contains all the modules of the JDK. And then I'll specify a command @modules java.logging, and I'll specify the output directory for my new JDK. For example, I'll specify D software Java. I'll name it JDK 9 logging only. It takes a few seconds for this to run. Now if I go to the directory where I created my JDK image, oops, yeah, I see I have a JDK created here in that directory. It basically has the same directory structure as a standard JDK, but it only contains the JavaUtil logging module. Now I've created that custom JDK. I can also specify it in Eclipse, just like any other JDK under execution environment. I can add a standard VM, and I can specify my custom JDK here. As you can see, Eclipse recognizes it without any issues. So far, so good. Now that we've seen basically that we can create a stripped down version of the JVM, let's see how we can also specify permissions for the modules of our ecosystem. As I mentioned, basically I converted all the applications, including the banking server, into Jigsaw modules. And the only thing I had to do is to provide module info metadata. For each one of them, basically I specify what are the exported packages. The banking server provides some APIs, and it provides two services which can be implemented by other modules. These are the banking application and the banking protocol service. The implementations, as you might guess, are provided by my protocol implementations, which are provided as Jigsaw services. And my demo application is also a Jigsaw module which implements the banking application service provided by the application server. What I've done basically, I've already compiled the Jigsaw modules using Java-C. And now what I want to do basically with those compiled modules is to see what will happen if I run my application server with the security manager installed. For that reason, I'll uncomment the security manager, and I'll just recompile my server module. I'm using Java-C for the purpose. First, what I need to do, I need to list the sources. I'm using a bit of a long command line here. Yeah, I need to remove some stuff from here. So it takes a while to compile my module. And now in order to execute my Jigsaw module, I'm using the Java utility. And with the Java utility, I specify basically minus module path. This is the directory where I've built my Jigsaw modules. And I specify that the main method is coming from the banking server module and from the application class. When it runs basically with the security manager installed, I can see basically that I have a security permission thrown. However, in that case, you might notice that I didn't have to specify any permissions for the service loader utility.load method as I did earlier without Jigsaw. And the reason for that is that in the module system, basically, in the runtime of Jigsaw, you don't need to specify basically permissions for the service loader utility, because it basically is part of the Jigsaw runtime. And when I run basically this, it tells me that my demo application that's discovered by the application server doesn't have the protocol permission in order to execute the fixed protocol. Now, how can I fix that? Any suggestions? What's the standard way to fix this issue? Yeah, we need to edit the policy file. And if I go back to my policy file, I can specify the root location of my Jigsaw modules. In that particular case, I need to specify for my demo application, which is a Jigsaw module. In that particular case, I specify the root directory of my Jigsaw module. And I specify that it has the protocol permission to execute the fixed protocol. I also need to apply the same permission for the banking server Jigsaw module. And when I do that, I run again my banking server, and as you can see, this time I'm able to successfully execute the fixed protocol. Now, there is another interesting thing in the security policy file that's provided by JDK 9, and that was if my modules were installed in the JDK runtime, which you can do. You can supply those modules installed as part of the JDK runtime. You can specify permissions for them using a new protocol, which is called JRT. There are some examples in the security policy file. And you can say, for example, JRT java.logging. And you can specify some permissions for Java logging. Or you can say JRT banking.server if your server is installed as part of the JDK modules. In that case, you can see it's much simpler than specifying the full path to the Jigsaw module. So that's one new thing that they've added in JDK 9. So as you can see, basically the security model is pretty much the same, with some new additions that provide you with the ability to specify permissions also for JDK modules, which is a very useful thing in many cases. And now, basically, we want to see how this security model that we saw in Jigsaw, which is derived from the standard Java security model, compares to the one in OSGi. How many of you have used OSGi or know about OSGi, at least theoretically? Okay, a few people. So OSGi before Java 9 was, I would say, the de facto standard module system for Java. It's highly dynamic. It's based on specifications that have been written and modified since more than 10 years now. And in Jigsaw, basically, in OSGi, the security model basically also depends on the standard Java security sandbox model. So apart from that, apart from the fact that it's an extension of the standard Java security model, the OSGi specification also provides a set of custom permissions, such as package permission or service permission, that allow you to specify whether OSGi bundles have the ability to import or export packages, or to provide, import or export some services. So this is one thing. The OSGi specification provides a new set of permissions on top of the standard set of Java permissions. Another thing is the OSGi security model is extended further with some utilities such as permission admin and conditional permission admin. This provides you with a more flexible way to manage permissions based on a set of conditions. For example, if a condition is true, then you can apply those permissions. Otherwise, if that condition is false, you can provide different set of permissions. So the security model in OSGi is even one level more flexible than the standard Java security model. Another interesting thing in OSGi is that you can specify local permissions, and this is the fact that every application in OSGi may specify its own permissions. And the reason for that is if you supply that application to someone for installing it in their environment, they can just open that permissions.pem file and they can see what are the permissions required by the application. It's pretty much similar to if you want to use, for example, your Google account to provide your Google account to some service. It asks you, okay, you need to have this and this and this permission provided to that application. The idea is pretty much similar here. You declaratively specify explicitly what permissions does your application require from the runtime. Now, compared to Jigsaw, both a Jigsaw module and an OSGi bundle have a distinct protection domain, which defines, as we already said, the set of permissions for that module or OSGi bundle. So in a way, basically that's quite similar between the two systems. And also both an OSGi module, OSGi bundle and a Jigsaw module can be signed, and basically the set of permissions for the signer, this is basically the user that's authenticated to execute that code, can have for the Jigsaw module or the OSGi bundle. However, the Jigsaw module is of course more limited. It doesn't provide the extensions of the OSGi specifications on top of the standard security module. For example, it doesn't have this notion of local permissions. In Jigsaw, you cannot say explicitly, my Jigsaw module requires this and that permission. And also another interesting thing is that in regard to OSGi bundles, as we already mentioned, at runtime Jigsaw modules can have classes from different class loaders. This means that one Jigsaw module can have different protection domains or different set of permissions for different parts of the module classes, which is not the case with OSGi. And as a summary of everything that we discussed, the new module system in Java brings better security, and at the same time it fits in the standard security architecture of the JDK that's been around from the beginning. And also the module system introduces yet another layer of access control, which is provided by the notion of exported or open packages. Any questions? Yes? Now basically when you start up the JRE, you can specify with the JVM argument what's the security measure you want to use. There is no need to install it as part of your application. When you start up the JVM, you can specify what's the security measure using a JVM argument.
Without code modification, yes?
Yes. Yeah, it's possible. You just use argument when you run the Java runtime.
Okay, thank you.
Welcome. Other questions? If not, then thank you for attention.